Here I am, and I will discuss some new theoretical developments in hydrocracking, in particular in lumping hydrocracking and the catalytic version of these reactions. And the study the study is motivated after the work, for example, of McDonald Italia, in which they are interrogating about the possibility to describe as a Markov process these types of hydrocracking. And in particular, I will show how to implement this paradigm to answer the interrogation. In particular, I will show how to choose the probability matrix for the Markov representation, how to write the generic state vector, and the evolution with the proper eigenvalues of the probability matrix, and then I will apply some results on the time evolution of the probability matrix. And I will motivate the study after the interrogations of some recent works in which the time description of these reactions about the description of these reactions, and discuss the industrial applications as for plants. And in particular, I will start describing the from the previous work of Buswit al. Italia, in which some kind of catalytic hydrocracking is analyzed by using nickel on alumina as catalyst. And I will discuss that there are no patents for the plants. So the work applies on how to time the plants once the plants are projected, and I will and the particular interest of the work is how to recharge the reactants in the plants. The method I will use is as far as the interrogation raised after the work of McDonald Italia, is to evaluate the mean first passage times of the states, where the states are the mathematical denomination of the quantity of reactants. And this allows to write the state vector, where the state vector is the quantity represents the quantity of reactants which are left during the reactions. So I will present some methodologies which can contain some mathematical details, and I will discuss the processes, industrial applications, and output. And I will show also show some different examples in which the transition rates determine the choice of the probability matrix in the Markov representation. So I have evaluated the answers for the interrogations of the different processes involved, and it's worth recalling that the industrial advantage of using catalytic hydrocracking is that the temperature of the plants is lower. So I am giving some items of bibliography in which where the experimental data are taken from. So in the item of bibliography by Budvita Italia, the transition rates are normalized, and in the following one, the transition rates are not normalized, so I will normalize them. And it is worth recalling that when the as in the second example, when the experimental error is not reported, it is possible to assume best experimental condition for the calculation of error. So, as I was anticipating, capital K are the transition rate which are not normalized, and small case K are the normalized rate. So here there are some mathematical definitions in which the vector, there is the vector chosen, the state chosen after the interrogation of McDonald, which is U0, and I am here writing the time evolution of the generic vector within the chosen representation of the Markov probability matrix, in which after the calculation of the time evolution of the generic vector from the Markov probability matrix, it is possible to further study and further specify the timing of the chemical reaction by studying, after the study of the time evolution of the eigenvalue, which is not considered in the former interrogation of McDonald and Italia. So, and here I make sure that the representation meets the requested mathematical prescription. So as an example, there is the four lamp exact Busvital hydrocracking, which from the items of bibliography was developed before the interrogations raised, which I am trying to answer, which I have answered. And there is the states are starting from vacuum gas oil, and I am reporting the numerical values of the rates with the error due to the experimental apparatus. And here I write Q, which is the fundamental Markov matrix, and P, which is the Markov probability matrix. And I specify that the entries P12, P13, etc. are small with respect to those specified in the fundamental matrix Q. And I write the specific vector at the time, the generic vector at the time T0, and I write the time evolution of this of the states, which is the time evolution of the catalytic reaction. Then I studied the modelization proposed after McDonald's and Italia, in which the probability matrix in the 3-lamp hydrocracking can be written, and the prescriptions on the evaluations on the entries are imposed, which follow from the numerical data. And it is possible to write the time evolution of the generic vector, which can be specified to the vector of interest for the previous interrogation, which is obtained by posing V2 and V3 equal to 0, but the expression I am writing is more general and can reflect more realistic functioning of the plants. And there is also the 3-lamps fast process, which is described after this fundamental Markov matrix. And the generic state vector is written. Again, I recall that the eigenvalues I am writing here are those calculated from the Markov probability matrix, but which as a first instance, but they can be the time evolution of the eigenvalues themselves can be studied. And then I am writing the generic state vector evolved after the Markovian dynamics, which I have established for the 3-lamp fast process. Then I recall the 4-lamps process, in which the transition rates, which I have normalized, are written for the fundamental matrix, and I am recalling the values. And I am spelling out for the clarity the expression of the eigenvalues with the time steady eigenvalues with respect to the transition rates after the Markov probability matrix. And I specify the order of magnitude of the sum of the entries of the probability matrix, which are not involved directly in the calculation of the state vector. And I can finally write the generic state vector. Then there is the fast process, in which the sum of the rates are taken equal to 0. And the fundamental matrix is written, from which a representation of the Markov probability matrix is chosen, after which the time evolution of the vector is. Then there is the catalytic process, which is where the catalytic processes are characterized in the Markov representation of the fundamental matrix as with entries from on the left side of the diagonal. And this way I can choose a representation for the Markov probability matrix with the properties of some of the entries, and I can finally write the evolution of the state vector, which represents the reaction, and it is possible to see how the different eigenvalues characterize the states of the vector, which is the time in which the reactants are involved in the reaction before the reaction runs out of the reactant. And it is possible to recall the fast catalysis in which the reaction is simplified as with the Poisson one rate equal to 0, and the catalytic features are recognized in the presence of K2, the entry of the matrix K2 in the left side of the diagonal, in the Markov fundamental matrix, from which the Markov probability matrix is chosen again. And there is also the decayed balance catalysis, from which it is possible to write the Markov fundamental matrix. I can choose a representation of the probability matrix and write the time evolution of the generic vector again. And as far as industrial applications are considered, there can be the further studies of hydrocracking and the kinetics of the hydrocracking. And then there are data analysis techniques which in which the modelings can be cast, and the relevance of hydrocracking in the industrial plants is about carbonaceous materials, and the study of reactions of carbonaceous materials and the features which are wanted for the plants. So for the catalytic processes, the experimental validation can be inquired after the choice of some design of experimental apparatus, and the statistical analysis of the processes, which is the study of the processes of the catalytic processes, has been proposed as far as I could find only as a thesis, PhD thesis, in which the stochastic approach is chosen rather than the Markov approach. Thank you for your attention.